Okay, to people joining this live stream, this is a Wolfram language design review, language completeness and consistency review, where we have a variety of topics to discuss. Okay, graph vertex names that are lists. Charles is presumably here, right?
Yes, I'm here.
Okay, so can you tell us what the problem is?
Well, you Stephen, sent an email to LCC with that first bullet point is the entire content of the email.
Okay, but Charles knows what the issue is, right, Charles?
Yes, I know what the issue is. So essentially, the use of list in graph have several issues, right? In most of the cases like that should work fine. But
Okay.
sometimes when it's used as a second argument and such, right? Yeah,
second argument of what?
Oh, so when you have a function like let's see, a function which need to take a vertex, for example, let's see, vertex component or out component.
Right? I see.
So
okay, let's take this graph here, and we say vertex out component of %22, and now we say list AB. Did that work or not?
Yeah, in this case, that worked. I mean, so that's why it's more, I classify this as more a bug, a general issue. We just need to go through graph and fix that. Essentially, we want both to be able to support, vertices and lists also, kind of listability for
right, but if I were to say graph A goes to C, C goes to A, A goes to C or something like this, and now I were to say vertex out component of that, comma, list AC, I can't even tell whether that's right or wrong in this case, right? So I'd say A goes to D, for example. Is this right or wrong?
It's right.
Okay, but so what is the what's a failing case? Okay, Charles, is this just a bug?
Yes, it's just a bug. Like the case of nested graph is just a bug.
So which is the actual bug? Or
I found the bug about nested graph 405251. Let me see if I can get an example from there.
There is nest graph where it's obvious, and there is also some function where there are corner cases, right? Where we essentially, if you give us a list, we need to check if it's, that list is first a vertex or is it a list of vertex. So some of the implementation for some function, we don't do that correctly.
I see. So you're prepared to go and do a content-dependent test.
Yes.
Now, I mean, you could have a weird thing where there's both the vertex that is a list and isn't a list. What do you do in that case?
So in that case, we give the precedence to the vertex. So if you...
Okay. And you're going to document that?
Yes.
But now what if, I mean, to me, it seems like if you really want the list, maybe we should be able to say verbatim of the list.
Yeah, we can actually also support that.
Fine. Verbatim is not a hold all thing, is it?
No. Verbatim is not hold all. Your hold pattern is obviously hold all, verbatim is not. And right, that's why the old literal was split into hold all and verbatim precisely to clarify those two different things. So verbatim is not hold anything.
Okay, fine. Okay, so it sounds like it's just a bug and we might have this verbatim extra functionality, but then we're done on this issue.
Yes.
Okay, good stuff. It'll be nice because nest graph is a mess right now.
So Charles, would that then extend to like the vertex replace case that I was discussing with you earlier this year?
I'm not sure. I don't recall exactly.
Right. So where I was trying to do, I wanted to do vertex replace of graph. List of vertices goes to list of coordinates.
Oh, right. Right. You wanted to have the left hand side, just one rule with a list on the left hand side and the list on the right hand side.
Correct.
No, unless we decided here. For me, vertex replace was more behaving like replace. So you'll have to match, the left to the right without doing a threading. It doesn't thread, you see.
Right, but part of the reason at the time that it couldn't thread was because the list on the left-hand side could be a vertex itself.
Right. That's also one point. Yep.
So, okay.
While we're at it, I don't want to hijack this conversation, but there were two other graph-related things that I wanted to raise. One is, at what point do we get to do graph rewrites? Because we now have tons of code from the physics project for doing graph rewriting. And it seems like we should figure out a design bridge so that we can actually do graph rewriting directly here. I don't know whether you've looked at that at all, Charles.
Yes, I did look a little bit a while back, actually, where we got some of the code. I think we should probably just put that in the list of project.
Right. Well, we probably should just do a design meeting where we try and go through. I mean, I think that there's a whole theory of what's called double push-out rewriting. That it all has to do with where the hairs of the rewritten, the pattern graph, how do its hairs, its tentacles, its I forget, they have a more technical name for it now. I used to call them hairs. The things that stick out that are kind of half edges, if you understand what I'm saying.
Yes.
How do those connect in? Okay, we should look at that. Okay, first point. Second point, graphs with ports. We're going to need graphs with ports. That is, you know what I mean by that?
Yes. Yes.
And why is it that syntactically we can't be using an association type syntax for, or am I crazy here? For basically what we have to do is label from a given node. I mean, like in our trees technology, we essentially have ports by virtue of the ordering of the edges coming out of a tree, of a tree node. But we don't have that for graphs because it doesn't matter. This thing here doesn't care what order it's in, right?
Right.
Do you have a suggestion for how to represent graphs with ports?
Yes, actually, I think I actually had a proposal a while ago. I will chase that down and probably have a meeting for the design. If I remember correctly, it was just actually more a wrapper where we can just specify the different type of port and associate it to the.
All right. So maybe we can get who's PMing here? I'm forgotten again.
It's Seven
Addison
and Addison.
now, yes.
Okay.
Addison's taken over.
Okay, great. Okay, so we should have a custom design meeting about ports in graphs, neural nets, tensors, because I claim they're all the same thing. And I claim, and this is something for Jose, I claim that the string diagram methodology, aka tensor networks, is all a story of graphs with ports. And maybe Jose can comment. I mean, when you have a tensor and you're sort of threading through different tensor indices to represent contractions and so on, that is effectively a graph, but it's a graph with ports because it can be the nth index of a given tensor is the one that threads to something else. Does that make any sense?
So can somebody define ports for me? Because
okay, so here's what I mean. So we've got a graph, and like let's take a trivial graph. Okay, let's take the graph. 1 goes to 2, 1 goes to 3, 1 goes to 4. Okay. Boom, there it is. Okay. Right now, this edge, you can say this is port number 1, this is port number 2, this is port number 3 of that vertex.
Okay.
Okay, but it isn't a label of the edge. It's a label. You can think of this as this vertex. So in neural nets, the way this works, we have this notion. I don't even know how. Let's see. If I say net graph here, okay, when I look at why is it that this raft has a habit of running away, which I think has gotten, why is that spinning? Why did that take any time to start up? Whatever. Okay. All right. So here, let's see, where is it showing this? Anybody know how this works here? What this is basically, the point is, go ahead.
Yeah, right. So are we thinking of this as sort of like slots in the tensor? So Riemann has,
Yes,
the first one is an up slot and then 3 down slots, and then you get Ricci by, you know, contracting the first and third, leaving 2 down slots.
right, but you can think of that as the tensor having ports.
Right.
Okay, so yeah. Oh, Jonathan is here. Why is Jonathan here? Well, I'm happy that Jonathan is here. He's commenting that dummy indices, the standard terminology in string. Well, but that's the term dummy vertices, as opposed to dummy indices.
Can you try what I put in chat, Stephen?
Yes. Yes. What on earth is this? Oh, what is that? Where did that come from?
It's one of the things that we were working on when we were developing symbolic tensors. So
Wowee.
The
Right.
black
So each
part
one of the
are the Riemanns, and the red parts are the contractions.
Okay, now Jonathan, who's revealed his presence, can you comment on how this relates to string diagrams? Or, well, okay, Jose and or Jonathan, Penrose notation, string diagrams, whatever, how do they relate to this?
I think this was, I mean, this is the idea of bird tracks that we have discussed sometimes.
Okay, so let me understand. So these black things are Riemanns. Is that right?
Yes.
And these red things are, but I don't understand why the Riemanns are connected. So each node here represents an index of the Riemann. Is that right?
Yes.
And then this is saying, but what we're not getting here is the naming of the ports of the Riemann.
Right. Internally, they are numbered. So one of these nodes is a 1, another a 2, and then tensor contract is just naming the ones that are contracted.
Right. Okay, I understand that. But so this will be a case where, I mean, what I'm trying to understand is when you have neural nets, for example, and or, you know, you're connecting, you know, in a net graph, you are connecting these networks. These networks are tensors, and you're connecting certain legs of one tensor to legs of another tensor. And that's being done with ports. Here, this is the, for a net with multiple input ports, port arrow data. That, by the way, somebody should note, Addison, that's for you perhaps, there's a font incorrect there.
Got it.
In fact, multiple of these are incorrect. Somebody goofed up here. Ah, sigh. Okay. I had never seen this before. When was this put in? Like a decade ago or something?
Yep.
That's version 9.
Okay.
I mean,
Well-
I don't remember, did we just think it's not useful enough, or why did we decide not to actually expose this? Because you see it's in the symbolic tensors context.
Well, we could certainly put it as a function repository item these days.
Mhm.
We were exploring ways of expressing the contractions, but I I think it was never clear whether this was the right thing, because as Stephen was saying, it's not clear whether a tensor should be a single node or a bunch of nodes as here.
Mm-hmm.
What are they in the bird tracky type world?
The standard thing is to have each tensor having a shape. For example, Riemanns are typically squares, but other tensors have shapes that encode their symmetries. And so.
But the symmetry of the Riemann tensor is pretty complicated.
Yes, but I mean, here I'm in the assumptions line. I'm not representing the symmetry, but we could. There is internally a symbolic tensor Riemann symmetry object. And then, for example, tensor reduce could realize whether this is 0 or not via the contractions. Things like that.
Sorry, I got distracted by something. Could you say that again?
Yeah. So the third argument of arrays can represent symmetries, and internally we have ways of expressing the Riemann symmetry. And then,
which is some permutation, some collection of permutations.
Right. Yeah.
Okay.
Right. Some of which have minus signs, and others of which do not.
Okay.
Right, but he didn't declare the symmetry; he just declared it a rank 4 tensor.
Right.
So
what I was saying is that the standard thing is to have the same tensor with the same shape. So here we see these similarly looking black tensors, but they have different shapes.
Yeah. Yeah. Well, fine, but I mean that we could as well in the Charlesian world have something where it's a ported vertex, which could also be a shaped vertex. I mean, we have not pulled out the concept of there's no high-level description language for shaped vertices. Is that true, Charles?
Yes.
But we could have that.
Yes. Especially that when you start to do drawing and grammatical language, and you actually need that.
Okay, Jonathan, who seems to be audio challenged, is sending through some. What the heck is this?
No, I didn't realize when I should speak.
Okay, well, all right. What is this? This is going to be a ZX. Oh wow!
It's a 4x4 matrix
represented in ZX calculus.
Right. So this is a tensor network, or if you like, a string diagram,
where each of these represents.
So each of the vertices is a 2x2 matrix. So the green vertices being z rotations about the Bloch sphere, the red vertices being x rotations about the Bloch sphere, and then as in any string diagram, it's when they're stacked in parallel. That's a tensor product. When they're stacked in series, that's an ordinary composition.
Okay, so to be specific here, this we have, don't we? We have a Pauli matrix. So this is the X Pauli matrix is that, and the Z Pauli matrix is this, right?
Yep.
So they would be Pauli matrices in the case where the phases are pi. So like the green thing that with label pi is a Z Pauli matrix.
Okay.
But more generally, that they can have arbitrary phases. But
I wonder whether we should give Pauli matrix a second argument. Is there any reason?
No, I mean these aren't Pauli matrices, right? They are just Z and X rotation matrices.
But in what sense? I see.
The matrix are they just the matrix exponent? Are they true rotation matrices? So they're the exponential of the Pauli matrices?
No, they're not. No, they're not.
No, okay.
Matrices.
Okay,
and
so they're ordinary rotations, so they're not part of the spinor representation.
No.
Okay.
But anyway, the point I was trying to make was a purely structural one, which is just that. So you can see this has 2 input ports, 2 output ports, which corresponds to the fact that there are 2. It has effectively it takes an input that is a tensor product of 2 qubits and gives an output that's a tensor product of 2 qubits. And so we in this particular way of representing it, we just show those essentially as vertices that are invisible, and where the ports are labeled. So here you can see the input ports are called I1 and I2, and the output ports are called O1, O2, as specified in the wire description.
So this description of a graph is none of the way that graph works or the way that net graph works, I believe. That is this idea of wires. Am I confused here? I mean, so this is giving a bunch of edges, correct? No, it isn't. It's
right.
but it's giving edges to ports. It's giving edges that go not to nodes but to ports of nodes.
Right. So again, in string diagram rewriting, you have the concept of a true vertex. Sorry. Oh.
Go ahead.
You have the concept of a true vertex versus the concept of a dummy vertex. So dummy vertices, for the most part, are treated just like ordinary vertices, but they have certain additional constraints. Like, there are obvious constraints on the out degree of a dummy vertex, for instance. So they obey almost the same properties as an ordinary vertex, but not quite.
So in some sense, Charles, can you talk about this? We've got tagged edges, right, Charles?
Yes.
How does this relate to tagged edges? I mean, in other words, you say, I'm going to fill the ports of a node. I don't know. What do we have? What information does a node have? It doesn't know about its edges, right? All it knows is it's a node. It doesn't know how many edges it's going to have. The edges are just filled in saying, I go from this node to that node, right?
Yeah, in principle, yes. It doesn't have any, I mean, we don't associate any information to the vertex, but it's possible to do that, but we don't. So we still keep it, completely abstract, that we have the vertex and the edge, which is pretty much just that,
Right, but it's the edge that is declaring what vertices it's associated with. It's not the vertex in any way saying, I expect this set of edges. Right, that's the difference. I mean, the difference is we've got tags in the edges, but we don't have any way in which there's matching of those tags to anything. It's like a vertex could declare, I expect edges with the following tags, in principle.
Yes, in principle.
We need to talk about this. Okay, the other thing that this is raising is turning a graph into a function. Because that's essentially, both of these are in a sense taking a graph and saying, I mean, just as netgraph does. Netgraph is a generalization of, netgraph is a bunch of contractions, basically. These are all, well, they're a bunch of contractions, outer products and contractions. And the question is, how would I get, just like in for example, in trees now, you can say treefold. Okay, here's a question. So treefold is an operation that takes a tree and uses it to create a value of a function. Am I making sense? That makes sense to anybody. Right, so this treefold here.
It's a value, not a function. It's like fault itself.
No, I understand. But what it's doing is, it is using this as raw material. Instead of a list, it's using a tree as raw material.
Right.
It's evaluating.
Right, but it's not using it as right, as an well, I guess to a certain, right, it's not using it as operations, right? It's using it as pure inputs to the external function f, not as representations of some operation.
Right, we don't have something which uses the tree payload to fill in the f's.
Right.
See what I'm saying? Whereas here, the graph payloads, the node character is filling in the functions. Here it's not so much. But I think there's a generalization of this idea of, just as we can evaluate a function that is a chain, f of g of h, this is the beginnings of evaluating a function that is where sort of the connectivity is defined by a graph. Does that make any sense to anybody? before we did neural nets, Tally and I had a proto design, which I'm sure I still have somewhere, for functions that would be sort of graph put together, if that makes sense. Is this making any sense to anybody? I mean, to me, this net graph, this, etc., they're all part of the same story. They're all a graph defines a way in which arguments of functions, aka tensors, are knitted together. I think. That is, this graph here, forget that the tensors have array elements. This graph here represents, these edges could just be an inner function. This represents an expression, basically. It represents an expression where certain dummy variables have been used. Yeah, I mean, it's an expression, as Jonathan is saying, I didn't know they were called this, but where there is a dummy vertex here that is being put in. So in other words, okay, so I'm going to make the claim. Actually, okay, there's a simpler case of this, which is just DAGs. Okay, so let's imagine that we have the expression f of g of x, comma y, comma, let's say g of x. It's a good example here. Let's say I don't know how to make a good example of this. My basic point is here, there are common sub-expressions here. And so there is a graph version of this. Is it the case that what these things are doing is basically that you could unroll them? Well, I'm not sure. Anybody understand what I'm talking about? Whether you can, okay, to what extent is this related to the DAG representation of an expression? I mean, we have the tree representation of an expression, but what about the DAG representation where we're combining common sub-expressions? Is that an example of this type of thing? Any thoughts?
I would argue it's subtly different. Sorry, is someone else?
No, go ahead. In what way?
Well, I mean, this is showing the compositional structure, not the expression structure, right?
What's the difference? I mean, composition means what's f of g of x is a composition, isn't it?
Sure, but you're talking about sort of getting the DAG representation by looking at common sub-expressions between two parts or something.
Yes.
Which, okay, maybe it's equivalent to the string diagram case, but if it is, I don't think it's not an equivalent I'm aware of.
Well, but you could unroll it, Jonathan. It's a question of evaluation, right? In other words, you could redo. You're saying there are two pieces that have to be connected, that they're somehow the same as represented by the string diagram. Well, go ahead.
No, all I'm saying is that the string diagram, what it's really representing is a generalization of ordinary linear function composition, right? It's talking about, okay, we've got each of these generators it will in general be a multi-input argument, multi-output argument thing, and they can and those functions can be applied either in serial or in parallel, and that's what the string diagram is showing. It's showing you essentially how those arguments get fed between these different functions.
Okay, so the big difference is that we don't normally have multi-argument functions. The big difference here is this is the beginning of representing, normally we have trees. We don't have things where there can be we have trees that accumulate to a root. Whereas in a lot of these things, whether it's neural nets or other things, we have functions that basically have multiple outputs. And in the case of a tree, there's a much more limited lexicon of ways that you can knit, inputs and outputs together, so to speak. And so, I mean, I think this is the beginning of, I think this is a pretty general issue of representing sort of combinations of functions in such a way that in a more general way. And to me, you know, we have graphs. The one thing we're lacking is graphs with ports. The other thing we're lacking is an evaluator for graphs, so to speak, if I'm not mistaken. I mean, just like this is the beginning of an evaluator for trees. For example, here's a question. Well, I guess with expression tree, so if I took this and I say tree expression of this, I'm going to get some goofy thing. What the heck is that?
It's an issue with it's a known issue. Don't get distracted by it.
Okay. All right. Okay. But in any case, look at what this did. This is essentially turning a tree into an expression. Imagine that we could turn a graph like this into an expression. I think the reason that's tricky is a piece of functional programming stuff that we don't have, which is if right now this function is returning a single thing, right? Whereas what we really want is something where that function can return multiple things and can be then plumbed to different places, right? And the only way we have to do that right now is really messy. I mean, we say, you know, x, y equals this, and then we use x and we use y somewhere. I mean, this is a generalization of the Curry applied, et cetera, story. This is a story of how things get applied to things, I think. Jose, is this making any sense to you?
I think so. So in linear algebra, we have contractions of two slots, and we treat the two slots on the same footing because a function of a vector can be also read as the vector of the dual. And so there is this symmetry that we don't have in normal expressions. In normal expressions, we always expect a clear difference between the function and the object to which the function is applied.
Yeah, okay. And also, it's not clear that you have to have, or maybe it's the analog, maybe a graph corresponds to the pairwise contraction, and it would have to be a hypergraph to do the non-pairwise contraction.
Right. There is also the multi-case, and we have discussed recently all these generalized contractions and the multi-contractions and how to express multi-contractions and things like that. So in linear algebra, contractions are always between two slots only.
Right. Okay, listen, we should break this off to a separate meeting, but this is the meeting is about, you know, ports and graphs, string diagrams, generalized contractions, tensor networks. Maybe we should call it the tensor network meeting. Addison, if that's for you, that's what we would need. Okay. Did anybody, Charles, have any further comment? I mean, we're not going to handle this here, but I mean, did Charles have any further comments he wanted to quickly make about ports?
No, not at this time. Probably we'll discuss that more in detail during the meeting.
Okay, fine. All right, let's move on. Okay. Oops. Let me just save this somewhere. Where am I saving it? Eek. Where do I save these usually? I guess I save this to this strange functional programming thing.
Yeah, there's also like an ILD folder, but that's fine.
Okay, all right. PrimePy reporting. Option report.
Oh, it's just that we did the implementation of the progress reporting before actually I was aware that we have a general $ progress reporting global variable. So it's just a basic update. There's no big issue here.
Okay. Oh, Sander has put something on our live stream. Sander says, congratulations on 12.3. Thank you very much, Sander. Much appreciated. All right. The question is, why does it not have a remaining time?
Because we have no idea of the time it will take to compute. So there's first, the warm-up stage of the PrimePy, where we do a, first basic computation from the lemma formula, and at some point we actually know exactly the time which will be, we will need, or pretty much an estimate. So.
Okay, so look, in this case with the progress reporting framework, we need to say unknown here. This is completely obscure what's showing up here, in my view. Itai, do you want to comment on that?
Just the fact that I think we the fact that it just says time remaining ...
Yeah, it's just very confusing. It's as if something, what the heck is that? 1M. Look, if it's counting in seconds, I do not understand why we don't just say 1:07.
Well, there's, I mean, arguably that's ambiguous, right? Because that could mean an hour and 7 minutes.
It's ambiguous if you don't see it counting up in seconds.
Right.
Not in the slightest bit ambiguous if you see it counting.
Right.
So if it's going to be counting, I think we should use this.
Okay. Yeah, I mean, I think it's using some general function that people are using, some time to readable string function that, so but we can dig into that.
Okay.
Remaining Devin and Addison, make sure to make a note of this for the next progress reporting meeting.
Yep, I got it. Got it.
Okay, I think this should say paren unknown. Totally obscure otherwise.
Yeah, I don't think unknown is quite right, but it's what's the word I'm looking for? I feel like we've encountered this before and we came up with a better word. But yeah, like estimating time.
But we can't. Sure. We don't know. I mean, if this is like how long is it going to take the Turing machine to halt? It's like we just have no idea. Really no idea.
Yeah.
Okay, next question is there any way we could say what it's doing?
I guess that's a question for Charles.
To say, yes, we know what he's doing, but you mean, I'm not sure that information will be useful to anyone unless you know the algorithm or what's actually running behind.
Well, give me a sense of what it would say. What could it say? Lamerizing. Not very helpful. I don't know what, but go ahead. But I don't think it matters that people don't know what it is, because if they're really curious, they go search for it and they find out what that is.
I mean, the first version we actually had we had actually an entry which actually tell you the method we are using, and from that method there is it's essentially like it's prime pi. There is an asymptotic term, and then there is the main term. So is that that main term computation we first do before we start to estimate the asymptotic part. So
Well then, Charles, look, to me, even if the things are somewhat complicated, I mean, the fact is you just launched your computer doing something. It's, the fact that it's doing something fancy that you don't understand is irrelevant. It still gives you some idea the creature is not dead.
Right. I mean, at the time there was one suggestion which we usually see that in pretty much all software. You have a a bar moving, a progress bar moving around, and which kind of states you that the whole thing is computing, or it's it's waiting.
Yeah. That's what this is doing. But we're asking for something which gives more information about what it's doing. That's the whole point. We've already got the bar. This is the bar. Here it is. Right? We're asking for a string that says what it's doing. Right? And what's the resistance to giving that string? That we don't know what to, I mean, if the string, how many different strings in this prime pi computation, how many different stages does it go through?
Well, I'll just presume that it goes roughly to 3 stages, so we can pretty much tell the different stage.
Then we should do it. Then we should do that. Okay, can any of those stages have their times predicted?
Except the first one where it is actually, but the remaining one, yeah, we know the time.
Then why aren't we saying remaining time blah?
Because we're still in stage one, I presume.
Stage one. Yep, that's the
I
right
see.
part.
Right. So like the export to video does something kind of similar, right?
No,
It says,
look, what's this? What's this? What's this?
So now we have an idea of the time. So we have, you know,
although I'm surprised that that the remaining time hasn't updated yet. There we go.
right.
Cute.
It's an estimated time anyway, too, right? So
Right.
hopefully not be 5 hours.
Yeah, it's generally an overestimate, but there you go. Right, and so the video export, right, has a similar problem where it doesn't know how long it'll take to sort of prepare the frames for export. So it says, you know, preparing frames for export with some sort of indefinite and no estimated time. And then it says, you know, exporting frames. And then it has the progress bar with the estimate. So it does something similar. It just adds a little bit of text like that. So I presume PrimePy could do something similar.
Okay, listen, the basic point is it is information to say it doesn't yet know how much time it will take.
Right. Should it say like TBD?
That's too obscure.
Okay.
Remaining time, paren, not yet known. That seems reasonable, not yet known in parens. Because the whole point is, you think, oh, why doesn't it know how long it's going to take? Well, I'm sorry, it just doesn't know yet. You see what I'm saying?
Yep.
That seems, you know, seems useful. And here, I mean, honestly, I'm much less interested in the method by the time I'm seeing the progress bar. My interest in what it's doing just imploded, basically. Although I still wouldn't mind seeing a string saying what it's doing. But I really don't like these MS things, by the way.
Okay.
I mean, DV on the live stream is asking, can all functions compute their time complexity? Profoundly no. Profoundly no.
I was going to say it also probably doesn't need to report 3 granularities. 2 is probably enough at any given time.
Oh no, let's give the seconds. Give the seconds. It's okay.
So the 9 hours, 27 minutes, and 15 seconds.
It's fine.
Okay.
It shows the animal is alive. Right, and it's overly precise, but you know, so what? Wow, are we actually going to get a result? Let's see what happens here.
Yeah, and right.
In which case, I'm going to complain about being in a 9-hour meeting.
Aren't there labor laws against that sort of thing?
Right. No, but well, congratulations to the PrimePy. Do we object to the fact that time remaining was an estimate that was wrong? I think no.
Yeah, you're always pleasantly surprised when it's faster, right?
I agree. So I don't think we should bother. I think we
Right.
should
If
just,
right. If it, and also if it tells you two minutes and it turns into 3 minutes, that's annoying, but fine. If it tells you 2 minutes and then it turns into 3 hours, then people will be pretty annoyed. So
right.
That's the case to avoid.
Right. Right. Look, I do think if there are strings, I think it'd be a good test case, Charles. If you can make up candidate strings that would represent the stages, let's look at them and see whether we think that they're reasonable.
Okay, I can do that.
I'm not sure I've ever seen the time estimate on an OS update be correct.
Right.
Yeah. Well, fair enough, and that's much simpler than what we're doing here. Okay. Let's move on here.
Okay, so the next couple of agenda items are potentially related, so it might be worth thinking about them together. So one is coming from Michael, and I think there's a bit more context that maybe he wants to provide, but it basically is, right, subscripted variables, right? They're considered functions of the main variable, and you know, and so you know, you
right.
can't
I understand. So there are several related things. There's the famous X sub 1 blank story. As you might recall, no, probably nobody here recalls this. Version 3, we were going to put this in. We had it almost all designed. I remember it was a 10-hour design meeting in the end. And in the end, I said, we're just not going to figure this out. We got to give up. Right. So that's the next question is, maybe Michael was involved in that. I can't remember. But
yeah.
You know, the issue is
we wanted to symbolize it.
Right. Well, what did we want to do? I mean, we want to.
I think we wanted. It was clear how to do it in the front end, but it wasn't unclear how to symbolize something in the evaluation sequence.
I see what you're saying. So you're saying the issue is we want R sub 1. You know, basically what we want to do is pack it into a symbol and then be able to unpack it. It wants to walk and talk like a symbol until such time as you say, well, what really was inside there?
No, actually, for most cases, we never want to look inside.
Oh, which you might, R sub 1, R sub 2.
Yeah, but rarely, so to speak.
But we could use symbol name or something to look inside. Right. So the issue is, you know, is there a way to say R sub 1 and to symbolify it? I mean, we're now 20, however many years later. We should be able to do this now. We've got all these. Yeah.
It's not just a matter to be able to do this. Say, like in a vein environment, R sub 1, it shouldn't need additional work to saying R sub 1 is not a transcendental dependence on R, because nobody would ever think of R sub 1 in this manner.
Well,
it is
I understand, but
F sub X as being function of X.
Right. In fact, people might think of F sub X as the derivative of F with respect to X.
Right.
Well, okay, fair enough. But there's several different issues here. One is, can we use subscripted variables as pattern variables? That's one thing. Second is, are they, you know, under what circumstances is R sub 1, for purposes of solve, for example, just a black box blob?
Right. And let me point out that, you know, we have literally dozens of such things, right? We have subscript, superscript, subsuperscript, overscript, overbar, superstar.
Yeah.
I could go on.
I know we do. We have a bunch of typesetting constructs. The question is, should a typesetting construct be considered a black box thing? And I have to say, I would have thought that that would be the natural assumption. And we never did that. You know, we've had these typeset constructs since version 3, but we've never done it that way.
Or let's say reversely, under which circumstances could we ever do something non-trivial with it? Because we can't do inverse function of subscript. It makes no mathematical meaning.
And I'm starting to get worried about Bessel J, because you can differentiate with respect to the index and that sort of thing. But your point is that then you would be using Bessel J and not J subscript. New.
If you use J subscript, you don't get a Bessel function.
Yeah, you don't get any Bessel.
Exactly.
No Bessel at all.
Yep.
You might in traditional form.
Yeah, but that's a different thing. It's got interpretation boxes and so on. It's not an issue.
I don't think that's true. right? I mean, certainly you can type in lowercase sign in traditional form, and well, if you start with Bezel and you ask for its traditional form, then yes, it'll give you a template box. But the question is there, if you do like J sub something and interpret it in traditional form, what will it do? And maybe we only did that for the trig and inverse trig functions, but
wow, in traditional form, it does auto bracket matching. How nice. Wow, that's a big disclaimer. What do you know? Okay, but this is a weird case. I'm amazed that that works. And what we do in traditional form is so different from what we do generally. It doesn't matter. It just doesn't matter.
Well, I mean that right. I mean, you took the output, right, and then you put it into an input cell.
No, I didn't. You weren't watching. I typed this.
Yeah.
Okay.
That was typed.
All right.
But then I think our point is now it's not a subscript expression; it's a Bessel J expression. And
yeah. Right.
So
yes.
Yeah.
Okay. So let's discuss the possibility that all typeset constructs become essentially black boxes for purposes of essentially mathematical operations. And potentially, I mean, what happens if I say table?
Yeah, well, that's not gonna. Oh, that did work.
I love that.
Yeah,
okay,
it works in plot also, and
but this.
Yes. Although I think it's I think that's an.
This is going to really wig out.
Yes.
Yeah.
I have to say that I don't think. I mean, maybe we need a more careful analysis. But I'm kind of wondering why we don't make these typesetting constructs able to be used to make as if black box objects. I mean, okay, so here's a weird case. Okay, let's say I do D of subscript, x squared plus 1, comma, min or something. I don't even know what the heck that did. That's just totally freaking weird.
Well, it's giving you the partial derivative of subscript.
Right. It's an unknown functions to all mathematical functions. So subscript is no different than f.
All right. So look, the thing I'm imagining is there are two levels of this. Okay. This blanks thing is a different issue. Perhaps so is the module thing a different issue. But in terms of the mathematical operations, I just think it should be treated as a blob of a black box. Convince me otherwise.
Well, it'll.
So how would this work? Like, would FreeQ say that that subscript of x1 is free of x, or we have to add special treatment for subscript to every mathematical function?
Have to add special treatment.
Right, which could be really, really.
Well, I think we need to inventory.
Performance cost, right? I mean, decent, right? Inputs to solve can be, hundreds of equations.
Yeah. How many backwards incompatibilities do we get if suddenly subscript and friends are atomic, which would cause them to be free Q of their arguments? Oh, that would be that. I imagine that would actually.
That would be horrible.
That would be terrible.
Yeah.
Okay, so a question would be, and by the way, what does System Modeler do with subscripted variables? It has a whole subscripted variable circus, doesn't it? Anybody here know about that? Why is this slow typing again? Why is this happening? I thought that was fixed. That this thing is not typing at full speed in this search box. That's for Addison to go poke at again. Shouldn't be happening. And somebody mark down the timestamp here. You can go see it happening.
Got it.
Okay. Okay. I don't know whether this is showing anything here. Let's see. Oh boy. Well, this doesn't happen to show anything. Let me just see in this case. Where are they? They're just equations with just tons of subscripts.
I think there is never really a problem because there you only have the subscripted one, and the subscripted one themselves are used. You don't have this R, R1, and R2 scenario. You have the R1, R2, R3 to Rn scenario. And then you can solve for the compound.
I'm sorry, what? Oh, I see. You're saying solving for all the R sub i's.
It's no problem.
Right.
In what case?
R is a variable also.
I'm very confused. What are you talking about? Are you talking about system model, or are you talking about the more general case?
Like in the system model scenario, you say have some state, and the state is some vector x and x1 to x20, but you never have an individual x additionally floating around.
Right. I mean, right. So if we took the solve output with 1 over r, and instead of solving for r, right, we called it 1 over little r, say, and solve for little r, there wouldn't be any problem. Right. And you could also solve for subscript of r1 or subscript of r2. It's when you mix a subscripted and non-subscripted variable that you get into trouble.
Which especially this differential equation example further down shows people do very frequently, that they say y of 0 is y0. That's a very common.
Right. So I'm coming back to my statement. Why can't we treat all these typesetting constructs as black boxes, as symbol-like things for purposes of mathematical functions? And I raised some performance issue, which I don't really believe, but we can address how one might deal with that. But other than that, is it the case that, let's imagine that there was a symbol representation of all subscripted objects, okay? And let's imagine that somehow, and that's what was used if you wanted to make R sub 1 blank. I mean, and let's imagine that the preprocessor for equations turned all these things into the symbol-like representation of the subscripts, did the equation solving, and then turned them back.
Right. It could just replace them with new variable. But it would be a performance hit for every equation you or every system.
I'm rolling my eyes because I just don't believe in this performance.
But it could be maybe restricted to the case when it doesn't work. When everything works fine, then don't do it. If it doesn't work, then try again and do more work.
I don't know. I don't think that's some.
Well, maybe.
Look, the performance thing is nonsense. I mean, we can solve that piece of engineering. If you really think that's an issue, let's think about solving that piece of engineering. Okay, so the issue is how to scan the expression to get all the typesetting constructs. I'm sure there are ways to do that with some of our internal hashing stuff and so on. That I'm just certain there's a way to do that efficiently.
Right, we do that for desolve actually anyway. We have some scanning to replace variables which look suspect for the later solvers. So we replace them with new model variables. The only issue is that someone need to know where to look. So we look in the dependent variable list to figure out what's worth replacing.
Okay, but
yeah,
go ahead.
You would have to scan the whole equation. So if you have like 1000 by 1000 system of linear equations, you would have to scan the whole system to see if it contains subscript over.
You know what? You're not going to sell me on a performance
It
issue.
may not be. Actually, it would have to
It's
be measured.
just
I
not
haven't tried to measure
an
it.
issue. It's just not
might
going to
not
be an
be.
issue, right? You're solving 1,000 by 1,000 symbolic collection of matrices of equations. This will not be an issue.
Well, numeric will have the same problem if you want unsolved to have the same.
Okay, fine. I'm telling you, there's a way to do this with hashing or some other method that we can figure it out.
It may or may not be a problem. It have to be measured.
Right, but so I can tell you for a start, to know that there are no subscripts in the expression is very fast. So we're out of the game in that case. If you set the thing up with subscripts, better that it work in finite time than it not work at all. So I just, that's not going to be an argument. So let's talk about the semantics of what it can do. Okay? So the question is, if what happened is every one of this list of typesetting constructs turned itself into an as if symbol in which any content was just invisible, right? And it can do that in a variety of ways. It could do that by putting a wrapper around it. It can do that. I don't know, right now you're probably using FreeQ to look inside, are you? Is that right?
Yeah. So it would have to just replace it with a variable, like generate new symbol and replace it with new symbol of x1 through xn or something.
A different possibility. You could not use FreeQ. You could use a new FreeQ.
Right.
Everywhere inside.
I don't care. I don't care. This is a stupid software engineering claim. Okay. If it's a question of, yes, the code is going to have to be changed. That's what happens when we change the functionality. Right. And, it may be much more efficient and more sensible to change FreeQ than to go pre-processing every expression. Is that the single place where it finds out that the thing has the variable inside it?
I mean, there's the other question of, what if it's subscript of y comma x?
Well, okay, there's a question of what we want it to do in that case.
Right. I mean, I think.
What do we want it to do in that case? I think it's tough luck. I don't think that's a function of x anymore.
So you're saying treat that as a new constant that
I
is
think so.
independent of both y and x?
I think so.
So are we making a decision on behalf of the user that we say this is constant, whereas the user kind of indicates some variable dependence? My only worry is that we can do it, but if we're going to do it, then we're kind of assuming that the user meant that. Is that safe to assume?
Okay, so your claim is
maybe one possibility is, we have a new option like opaque heads goes to automatic, and so subscript and whatever other typesetting guys go into that, and if people don't want that, they can, they make it empty list, and if they want to add their own custom ones, then they can add those.
Right. I think the question is the default y sub x. I don't know. I'm not sure about that. I worry about it because I can think of a case, what's a good, y sub I, or no, y sub, let's say y sub min, you're unlikely to have something, y sub min probably means you don't want it to be a function of min, right?
Yeah.
Now, y sub s, for some reason, I'm thinking that that's less clear to me. Is that a constant or is that a function of s? Y sub I, actually y sub I is a great example. Y sub I could mean the initial y, or it could mean y that is somehow implicitly a function of x, of I, sorry. Do you get what I'm saying?
Yeah.
So what do we do with a case like that? Okay, so we have this, and I think it's going to wind up having to have a wrapper. I think that the question of what the default is, I tend to think that the default should be, okay, let me give an example. So if I have, let's say we do this. Let's say we say, okay, so here's a weird case. All right, so let's say we say solve x squared equals 4, x with respect to x. And now I take that x there and I make it red. Okay. Kaboom. It ignores.
Yeah, well, that's an irrelevant example. Because the kernel never sees the red. The front end strips the red before it ever sends anything to the kernel.
Yeah. Look, the fact that y sub I is a typeset construct, not a thing. Well, okay, okay. My tendency, I agree with Itai that having an option that determines how these subscripted things are handled is a clear escape valve for that. The thing that I'm still interested in is there a way to solve the y sub I blank problem?
I think that's a bigger.
I know, but maybe we can solve it at the same time. I mean, the question there is, look, actually, okay, here's the obvious solution to that. Here's the obvious solution. The obvious solution is in the parser. If you type x sub I blank, simply, in 25 years ago, we were afraid of doing something like that. But in other words, to basically change it syntactically to just be the symbolized x sub 1. Right? Which suggests to me that we need something which says, if we say symbol, how does this work? If we say symbol quotes x, right, we get x. If I say symbol x sub 1 quotes x, splaffaroo, right? There's no good reason that shouldn't work. The symbol table shouldn't care. I mean, so long as it's canonical, the symbol table shouldn't care whether what it has in it is. I mean, I think we were afraid of linear syntax and things at the time. So I'm saying that, in my opinion, should work. And what should happen is, I think, okay, good, we've gotten better at design in 25 years. I think what we should do in a case like this is that the parser should turn that into symbol of x1, symbol of R1. An actual symbol.
And how flexible is that? Could I have an symbol of an unevaluated integral?
Right. I mean,
you should be able to do that. But I already realized the problem with this. It's all well and good to do that in the parser, but what about the right-hand side? Right. If I say f of xi blank colon equals xi squared. Oops. How do I make that work? Okay, so the other possibility is that the pattern object that is x sub I blank could take something other than a symbol on its left-hand side.
Right, but what you have on the right-hand side, it doesn't have pattern in it, right? So I think
no, I understand that, but this is, look, this is the same x. This thing here, right, is pattern x comma blank.
Right.
Why do you think there's a problem? No, I'm just saying that the name of the object is x sub I.
Okay, and what happens if there's this x and an I on the right-hand side? I guess you're saying they
plus
would
x plus I, they're irrelevant.
Okay.
those are no more visible as being like x sub I. I mean, in other words, gosh, it would be nice to solve this problem. It's been a long time. I think this, well, let's see. Okay, the final problem is the module variable problem.
I mean, module variable, I think is, to me feels like it ought to be the easiest of them.
Because it's lexically scanned anyway.
And I mean, it literally does a replacement.
I know.
So, it's just a different replacement.
Right. But the question is, I think, so I forget who was just raising that, is how general can it be? Is it just subscripted variables with subscript and so on? Are we treating those now as semantically significant? I think that would be pretty adequate. I mean, the set of variables that I've needed that are, annotated variables, it's a very definite annotation list. It's things like overbar.
Well, okay. I mean, so the thing is that in addition to subscript, you have a lot of people who, because they work in text editors or whatever, don't use subscript. They use X bracket 1 bracket.
Okay, well, that's tough luck. I mean, then they're not using, it's tough luck. We can't deal with that. I mean, that's a different thing. That's the question of what the default behavior here is. I mean, for example, that's a different question, which is a perfectly reasonable question of what happens if you say solve x sub 1 squared plus x squared equals 1 with respect to x sub 1. Okay, that was fine. Now, what happens if I say solve it with respect to x? Okay, how did that work, guys?
Oh, the free Q doesn't, head is false by default. So it doesn't find the x in the head.
That's extremely fragile.
Really? Or are you saying that free Q is setting heads goes to false?
No, I think
which is not its default.
If you say free Q
nonsense of x, I mean, in the generic case
x1
of
x, does it say false or?
It's
or maybe
no,
it's just...
heads goes to true for free Q.
Yeah, the member Q defaults to heads goes to false.
Right,
yeah, but free Q,
but
right.
free Q.
Okay, but so what has been revealed here? Yeah, well, heads goes to false. It'll do that. What has been revealed, Adam, is that were we to add an option to free Q, your claim, you could just you are already using free Q with heads to false.
I'm using lead present Q in the C code, which might have a different setting for default.
Okay, whatever, right? But whatever. But I mean, okay. But the fundamental point is that we could as well have a setting to free Q, which would be interesting, which is don't go inside subscript and so on. Right? We could say, I don't know what it would be called,
Right, but
ignore
I don't
type
think we could possibly change the default values.
No, absolutely not. Absolutely not. But we could certainly document that these mathematical functions are effectively using free Q with that option. Am I making sense?
Yeah, that's a possibility.
Right. There might be some implementation problems, like
I don't care.
Yeah.
No, I think it works
because
yeah, if you have an option, then we can globally have a new internal function which does exactly that option setting once, and then everyone else picks up. So
guys,
yeah.
you are fine software engineers. You can solve this.
Yes, absolutely. It's not difficult. I agree.
Okay. Sandra is commenting on using head exclusions in free Q. Yes, something like that is probably right. But if we did this, then we would solve the problem of the math functions, burrowing inside these things, right? So that would solve that problem. Now we still have the two outstanding problems, as far as I'm concerned, of x min blank and what's the other one? And the module variables. Right.
Right, but yeah, right. Well, okay. Well, what about block?
Does block work with X sub 1 right now? I think it does.
No, it requires symbols.
Okay, why is block any different? Because
well,
it's assigning. I see it's assigning values. Okay. Yeah, that's complicated. Look, solving this for the math functions would be a good start, but I really think we should, as part of this LCC series, we should readdress this question about pattern variables.
Okay.
But let's investigate this free Q modification to deal with the math functions, and that I think would solve Michael's problem. Is that true?
Yeah.
Great.
Right. Just don't necessarily expect it for 13, because I don't see this being a small project. I mean, it might, but we certainly can't promise that without, once we're significantly further along in development.
Understood.
Craig is making a comment about matrix form, and it's a good and interesting comment, and let's look at what he's saying. So the main issue is, given a matrix, that was beautifully formatted. I do so love this auto matching thing. How we could have survived without auto matching in the past, I have no idea. Okay, so now we say inverse of this. Of course that works. Never mind, that works.
The problem would be, and
taking this.
That will also work.
Why does that work?
Because of the tag box structure tells it to remove the matrix form.
The
problem you get into is when you say A equals matrix form of blah, and then you try inverse of XXX. Right, because when you refer to percent, the out says / matrix form. So out removes.
Okay, I've got a comment here. One of the things that's a slippery slope that we have slid down in these years is differentiating inactivated things.
Mm-hmm.
Right, there was a time when if it didn't have the right form, you didn't do anything to it. See what I'm saying? If I say, inactive, if I say inactive Bessel J, 0x, okay? In the past, we'd have just said, you're out of luck. It's not going to differentiate. It's going to give some weird thing. But now we are differentiating through the inactive. Am I making sense?
I mean, technically, we added an active and a differentiation rule at the same time. I mean, you couldn't have asked this question before we had the capability to do it.
Right. So the question is, why are we not doing matrix operations through matrix form?
That would be a very good solution, because we've been struggling with that, or you change the typesetting. But I think the easier solution is just to allow matrix form inside linear algebra operations. So then if you say
right, well, yes and no. I mean, I don't think plus wants to be in the business of, I mean, if you're talking about inverse and that, maybe,
yes.
But I don't think plus wants to be in the business of suddenly.
How could you make that distinction?
Well, that's part of the problem.
Right,
Oh,
and
okay,
sparse
but
array, I was going to ask, sparse array of matrix form. Or, yeah.
Sparse array of matrix form or sparse array of, what's wrong with that?
Well, it's not a linear algebra function.
Okay, but why not? Okay, question. Okay, so for plus, okay, plus is listable. Why isn't plus also? I mean, okay, so the problem that would arise is you have a matrix form thing, you add, you say +1, the thing blows itself out and it now returns lists. Right? So you might say that's bad because you started off with a matrix form and you ended up with lists. Mm-hmm. On the other hand, it's probably even worse that it is dumb as a stone and doesn't do anything. I mean, to ask a radical question. What will be wrong with having matrix form be essentially listable? Or some version of listable, some analog of listable?
Well, then it wouldn't work, right? Because it would evaluate.
No, I get it. I understand. It can't be outside in listable. It could be such that it is transparent with respect to listability.
That would be a question for Rob. I mean, conceptually, I mean, right, we do have a couple, right? So sparse array is an exception, and structured array is an exception. So I guess the question is, could we add matrix form and maybe also table form? I'm not sure, or do we really think matrix form is much more?
I'm not sure about that. That's a further issue.
But I think
Rob
I asked Rob the question.
Right, and then the second issue would be: can we make the obvious things that think they're eating matrices accept matrix form?
Right. Well, I guess one of the question is, right. So like inverse, right? It quietly sits there until it receives an actual matrix, which allows you to write things like inverse of A and do things.
Absolutely. Right.
And so the question is,
but this isn't going to cause a problem with that. It's not going to. This isn't a masquerading as symbolic thing.
Right. So you're saying only a matrix form that contains an actual matrix inside of it would disappear.
Yes, a matrix form that is matrix form of A or something, just like whatever. I don't know what to do with that.
Mm-hmm.
And should it preserve it? So inverse of a matrix form, should it be a matrix form too?
That would be lovely. Let us investigate this. This is a good idea. We should. This is one of those kind of ridiculous, trip up things that's been there for forever.
Yes, at least now it's properly documented. Ian and I, about a year ago, actually clarified all these. There were so many bug reports that we went in and updated the documentation, so it's actually clarifies what the behavior is.
Fair enough. But okay, I think it's a good. Thank you, Craig, for that, for pushing us on that.
Itai, when you were working on some of the matrix, the linear algebra docs recently,
yep,
were you using matrix form for matrix form of some particular matrix plus matrix form of some other particular matrix to do sort of pretty looking arithmetic?
No, I never did that. I might do something like open paren A equals mat close paren / matrix form. So the original input looks pretty, and then I do A plus whatever, or operation. Of course, that's partly because I know about this issue, and so I didn't want to have wrong examples. And so I wrote my code in such a way. But I'll be doing more cleanup of the linear algebra pages 413. So I could think a little bit about. I mean, on some level, I don't really want. I suppose if it's 2x2 or 3x3, but even then, matrix form can pretty quickly eat up a lot of space. So it's not necessarily such a nice thing to put in an input. It's great for the output, but the input is not necessarily.
Also, nobody knows how to type it. It's a mess.
Right.
All right. This is a really good thing. Let us explore it. Let's bring it back for another meeting. Go ahead. What are you going to say? Nope. Okay. All right. Let's move on to the formal operators question.
Yeah, I will point out that it is 5:30, and this is.
So we should wrap up soon. But let's just take a quick look at this.
Yeah.
My gosh, what is all of this stuff? Okay.
I think the relation here is that in the previous meeting you were suggesting a wrapper around, say, alpha. A formal, B formal, to have a symbolic AB and things like that. So we thought that it might be related with subscript X1.
Sorry, I'm sorry. What is this about? This is about. The issue is, how symbolic is symbolic? at some level. Like, for example, we want to have an axiomatic theory that is, aren't we getting, we're going to get a whole bunch of new ones, aren't we? Isn't that, does anybody know about that?
Try field axioms, for example, in which we are using now a tilde instead of an equal. So one of the ideas was how do we introduce a nice new equal there, which is not the standard equal. And so in the same way that we have formal A, we were looking for formal plus and formal AB, things like that.
I think we should have those. I mean, why don't we just use dots? Why don't we just go ahead?
Right. Well, I mean, that was Jose's idea, and you thought that was too limited. You thought there was a much more general issue and wanted this big discussion, which is why.
What was the, okay, so wait a minute. Jose's idea was just have a class of new symbols, just like we have formal letters of the alphabet, to have formal things for our various infix operators.
Right, formal equals.
Right.
And
okay, so those things would have, how would they parse? Like equals would be a binary operator, yes?
Well, I guess we could make it a formal equals, a binary.
No, but it has to be something, right? Because it's the whole point.
Well, our normal equals is not binary, right? It's n-ary.
Oh, I see. I wasn't even thinking about that point. But from a parsing point of view, I don't even know how the parser does it. What does the parser do? If I say A equals B equals C,
then you get
full form.
Then
does it
you'll
flatten?
have a single, yeah.
Yeah, it auto flattens. Okay, so clearly it should not auto flatten. The formal equals clearly should not auto flatten.
Okay.
And honestly, it's a little weird because we're going to have everything, formal element, formal this, formal that.
What properties from the original one does the formal
Parsing
still have?
Right, and for example, right, equal and less equal all have the same precedence, and if you mix them, right, you get this inequality thing that preserves the flatness. So if these guys are not flat, then they're going to parse differently. Maybe we don't need a formal less equal. Maybe we only need a formal equal. But
well, who knows if we need a formal less equal? I mean, that we're doing lattice theory or something. Don't we need a formal? Okay, the problem is this: even the parsing might be wrong in the formal. Okay, this is a question. I looked at this back in version 3. Okay, the big surprise was that even of these things that are used only formally, like circle plus, the parsing precedence was surprisingly consistent. Am I making sense? That is, you look at random formulas in mathematical logic, people do not have different implicit precedences of operators between different formulas, mostly. Anybody want to comment? Jonathan, do you want to comment on that?
I mean, that sounds right.
It's not self-evidently correct because I mean these operators might mean very different things to different people. But that was my observation at the time. Yeah, Sandra is commenting that the word formal has never been used. Yeah, I know actually. It was sort of being reserved. And the problem is that if you say formal is a wrapper, it's already too late. I mean, so let's take a formula that we want to be sort of formalizable. Okay, so predicate logic. Jonathan, give me some predicate logic thingy dingy here. Let's say not B. Okay, let's imagine we're dealing with that, and we just want it to be completely formal. We don't want the not that we all know. See, okay, let's zoom out for a second. In terms of symbols, we have had the convention that things that start with capital letters could have a built-in meaning, whereas things that don't couldn't, right? That convention has stood us in good stead for 35 years. right? We do not have a similar convention because operators have special parsing. I mean, I think I had discussed before the possibility Okay, here's a crazy possibility. Okay, I'm going to give you another crazy idea. No, it's too crazy. Okay, the idea was this. Imagine that we had a bigger keyboard which had some special character on it, just like we have escape, for example, right now. Okay, do that. All right, imagine that, and this is kind of crazy, but imagine that before you type, you type A, and normally you get an ordinary A. But to get a formal A, how do you get a formal A? Do you say .A? Yes. So escape.a escape, which is clearly, 4 characters instead of 1. And then escape.equals turns into that. Well, great. Well, double equals doesn't mean anything. So at the very least, in terms of, it just seems so weird. I mean, we could certainly have a utility function that will take, okay, look, this would be a kind of, oh yeah, this is an interesting idea. Okay, I've got an idea. To formal expression. Okay, so I type in here, I type A plus B equals C. Okay, but this says to formal expression. And so that instead of parsing it with the normal parser where A means A, it parses it with the, the formal variable parser where that means A dot and plus means plus dot.
What does it do if you have AA?
What do you mean? If you have this AA variable here?
Yeah.
Well, somebody should mute themselves or their phone.
Sorry, but right, and I mean the other problem is what happens when right. So that equals, assuming we're using our parser, that equals is going to be flat, or we'd need to write a new parser which is almost exactly the same as ours, but somehow treats equals and a few other things as not flat.
Well, the issue is flattening. Is that true, or is there any other operation that is done? I mean, the precedents we'd be leaving the same. How disastrous for mathematical logic would it be to make equals be flat? Anybody have any idea? Jonathan, anybody else?
Pretty disastrous for how we have things set up right now.
Because it's a binary operator right now.
Right. So the theorem prover can't deal with operators of variability. Which is why it causes so many problems when we use like Boolean logic operators and things, because and is flat.
Well, why don't we just make the theorem prover go and bunch them up into binaries?
I mean, it could, but then I mean that would essentially involve us having to tell the theorem prover explicitly which operators should and shouldn't be deflattened. That was the only reason for not doing it.
Well, hold on. If the theorem prover, okay, we know the operator and is not, the theorem prover can't handle n-ary and today. Maybe one day it can. But the innards of the theorem prover could just, if it sees a ternary and, it could just turn the ternary and into a binary, into a pair of binary ands. Why would it not do that? Otherwise, it's dead in the water.
Well,
and it knows it's an and. Well, go ahead.
The flattening occurs before the kernel even sees it. That's part of the problem.
Yeah, but should equal be flat? Like A equal B in parentheses equal C is not the same as A equal B equals C.
Well,
that's
not going to parse flat. Right.
Yeah,
if you look at the full form, I mean, you can see from the formatting, but also if you look at the full form, you'll see that that's an equal of equal.
Yeah, right. That's a different thing. The issue is The issue is this case, A equals B equals C, because our equal is n array, right? But wait a second, Jonathan, hold on a second. You're saying that, I mean, the mathematical logic case, is it parenthesized? What's this supposed to mean? In the mathematical logic case, what on earth does this mean?
Well, presumably it would have to have some default associativity.
No, but I'm asking,
just like rule,
yeah,
right?
no,
I mean, right? If you do A arrow B arrow C, right, you'll get a rule of rule.
Sure. No, but I'm asking Jonathan if he's saying
in the deductive inference rules for equational logic, A equals B equals C would be parsed to A equals B and B equals C, and then you'd use the transitivity property of the equivalence relation to handle the rest.
Okay, so this one here, by the way, why is this giving a little twitch when I move over this? Something was twitching there. Did you see that? Did people see that?
I'm not seeing it over Zoom, but it might be. I mean, if you actually click in between, right, it's going to tear them apart because right there, because of the operator.
Oh, that's new. Yes, it's new. Right, that's
right.
new.
So as you cursor through compound operators, then you see the individual bits in case you need to change one of them.
Wow. Well, many unintended consequences. Okay, never mind. I'm not unhappy about that. I was just surprised. Okay, so Jonathan is saying this thing should turn into A equals B and B equals C. Well, why don't we just do that in the theorem prover?
No, we could. But the point I was making was just this is part of this more general problem, which is, essentially the front end flattening stuff before the theorem prover even sees it, and it seemed like we needed a general solution to that problem.
But hold on, equals. Okay, the question is what's in the sort of meta logic and what's in the actual formal thing? Because are you saying that equals is at some level of meta logic or something? Is that right? Equality. I mean, you can treat equality in two different ways, right? In the equational logic theorem prover, you're treating it as a meta thing. In the predicate logic theorem prover, I believe you're treating it as just another predicate. Is that true?
This is true, but from a pure logic standpoint, there's no difference between the two. That's a theorem prover implementational detail.
But in a case like field axioms, we cannot use the true equal because there is a rule saying A equals A. We cannot let that evaluate.
Well, we certainly can't let it evaluate, but if we had an equal, the issue here is what about the parsing, right? So right now, okay, let's just understand a dotted equal, a formal equal. What rules both does it have? By the way, I do like this approach. I mean, maybe people think this is crazy, but I do like this as a way to not have the incredible pain of entering, a lot of dottiness in it. What do other people think about that?
Well, the question is, how would that then format?
And also, how easy is it to see as you're typing that you're making mistakes typing into a string?
It makes it seem like the right thing would be a control equals like form for formal expressions. Right? If we had a thing that was, control something or other for why is that asymmetric? Why is that asymmetric?
Is what asymmetric?
Well, the
there's more of a vertical line below the equals than above.
Oh, I see.
And yeah.
Addison reported we're 150% magnification, some goofball thing there.
Got it.
I pasted something in chat that may or may not be
horrifying.
relevant. Okay, and then do release hold of that. Right, so this splitting apart things into ends is something we do via evaluation, and it's just so happens that with equal, well,
we don't need to.
If we have a single operator, right? Because if you had if both of those if both of those inequalities were in the same direction, right, it would stay as a single less than, say, right? So it's only in the
Yes.
case we've made the decision that if there's only one operator, we keep it as a big thing. And then if there are multiple ones, then we split it into the and. But there's nothing preventing the theorem prover from deciding it wants to, split things up if it wants to.
But Jonathan, the problem is, okay, the thing can never hit evaluation. The question is, what properties? Okay, several points. First of all, although it feels very heavyweight for something that seems to us today a bit obscure, the concept of a control equals like thing to enter formal expressions where we still have syntax coloring going on seems like a not totally crazy idea. Comments from people.
I'm worried that it might want to formalize too much. We may have objects there that shouldn't be formalized.
Like what? Like equal signs?
Some other variables we are using from outside.
Okay. Well, okay, so that's a fair point.
Right. Like, how would we deal with the case as we have in the field axioms where you have two equals operator, two equality predicates, one of which is formal, one of which is not?
Oh, God. Okay, let's zoom out for a second. What is really going on here? What's really going on here is we have both the quotes logic, the language of the logic, and we have a meta logic. Is that correct? And the operators in the meta logic are real and evaluate things. And the operators in the quotes logic that we are sort of playing around with predicate calculus and so on, is not. Is that correct, Jonathan?
Yeah, yes, except they're not operators in meta logic as meta logic is conventionally defined. It's simply that there's a distinction between operators that are defined algebraically through an equational theory and operators that are defined sort of programmatically via the theorem prover.
Well, explain to me why that isn't meta logic, by the way. Because the meta logic is the deduction rules, not the
Right.
equality things and so on.
Right.
Okay. But there are things that are structural.
Mm-hmm.
I mean, implies, is that part of, implies is something that is not down at the level of the predicates that are being tossed around symbolically. Implies is something at a higher level, correct?
Well, actually, no. In the theorem prover, it isn't.
I know in the equational, because you have an equational logic theorem prover,
right,
everything is just being turned into predicates.
Right, everything except the equality. Right, the one operator that's different is equality.
Right.
That's the one that's defined just in terms of the algorithm. There's nothing.
But now in ordinary, just so I understand, in what is even the name of it? I mean, it's modus ponens based deduction. The implication is special and equality is not special. Is that correct?
Right. Yeah. So in the sequent calculus, implication or semantic entailment is the distinguished operator, whereas in equational calculus, equality is the distinguished operator.
All right. So the claim is that there are deduction rules. There is something that is used for the deduction rules. There's something that in our world is the edges of the multi-way graph. Is that correct?
Yeah, you can think of it that way.
Which could be entailment, or it could be equality, or whatever. So, I mean, in a sense, what we have is the edges of the multi-way graph are unlabeled, are untagged, because we only have, because in any given thing, it's either sequent calculus or it's equational calculus, equational logic, whatever that's called, etc. But so in other words, the edges of what entails what are just, we fix that once and for all for any one of these things that we're dealing with. Is that a true statement?
Right. And and those operators in the current way that we set the thing up, those operators are not formal. So like when we do predicate logic theorem proving, the implies is not formal.
Right.
Well, the equality is not formal. So if you wanted to have a two formal expression input, kind of, as I guess this is a special case of the problem that Jose was flagging up, it becomes quite hard for you to enter anything into the theorem prover, because you would need to have a way of flagging that something shouldn't, that an operator shouldn't be formalized.
Well, and what you're effectively saying is, and this is descending rapidly into the mud, is that we really need a sequent calculus one, an equational logic one, and so on, which already know that their special things are such and such and such and such.
But how do you specify whether you're using the special version of the operator or the non-special version of the operator? You still have the problem.
You need to have some escape, right? But because, well, you're saying, okay, so here's the question: could there be two equality? I mean, this is the point. You're freeloading on our notation in a sense. You're using. I mean, okay, in version 3, we had this plan that we were providing lots of essentially non-meaningful syntactic forms like circle plus, which people could then attach to things. Just like, okay, so here's the question of why didn't it work out? Okay, in math, in standard math, people typing things with tech and so on and so on and so on. Something like circle, let's say circle times, right? There are a zillion different uses of circle times. It's been recruited for things in group theory. It's been recruited for things in tensor algebra. They're somewhat related, but they're not quite the same, right? Circle plus could be recruited for many purposes, right? That's what I thought was going to happen with our non-meaningful operators. Now, arguably, the reason it didn't happen is because people wanted, non-meaningful all the way through. That is, we gave them things which were, and even later on, we made things like element, for example, that had been non-meaningful, then become meaningful. Does this make sense? So you might have thought that in all of our formal stuff here, we're using circle plus here, which is one of our family of non-meaningful operators. The argument would be maybe we just don't have enough non-meaningful operators, or maybe we need a better convention for how all the non-meaningful operators would work. Anybody want to comment on this? Michael, do you want to comment on this?
Sorry, I had problems unmuting. It seems very heavy somehow.
Which seems very heavy?
This permanent distinction between meaningful and non-meaningful.
Well, the main problem is if everything was full form, there'd be no problem. The point is we're trying to use syntax. Does everybody agree about that statement? If I could just use plus with a lowercase p and all that kind of thing, or even something called, field theory plus or something. If I was able to do all of this stuff, a very heavyweight full form, then there'd be no problem. The difficulty is we're trying to kind of piggyback on our syntactic structure.
That's certainly true for the theorem proving case, yeah.
So the issue is, and when we piggyback on the syntactic structure, certain things we are grandfathering over from the meaning-based case of the syntax structure. Like, for example, we're pulling over precedences, we're pulling over associativities, which may or may not be. I mean, the precedences we're toast. There's nothing we can do about that. If we blow up the precedences, you might as well not be using, syntax. If you see what I'm saying.
But we also kind of take over the meaning. Otherwise, in some sense, the meaning. Otherwise, we wouldn't use the symbol in the first place. If like the plus would not in some form represent plus, we wouldn't use it.
I agree, except that it is a very generalized plus.
Right.
We're happy. We don't want any of the rules that are in the built-in plus. We don't want them touching us. I mean,
we could have as a convention, they go into a context, and there they format a slightly different way?
Okay, that's an interesting idea. Okay, so that's an interesting idea. Okay, so what are our possibilities? Use different symbols. Okay, use a context. Now, in a context, okay, use a context. Now, the problem with a context is plus doesn't parse differently in a different context, usually.
But you would have to write it out.
PLUS.
Yeah.
Then you've lost the game.
Right. Well, I mean, it's worse than that. So so this behavior has existed basically since version 3, which I presume was some attempt along this discussion we're having right now. But do foo backtick plus of AB. But now, if you copy and paste that output and do full form of it, you will get the system plus, not the.
Gosh, why? How does that work? That's crazy. What happens if I say foo of like, let's say Bessel J?
I don't think that'll do anything because it's not associated with an operator.
This is crazy bonkersville. I had no idea this happened. Really? Why did we do this?
I think you need to ask yourself of 25 years ago, or possibly Neil. I like I said, this has been around for a very long time. John may know a little bit about it, but it's something that people run into every now and then, and so I am aware of its existed.
It's crazy. It seems completely bonkers to me.
Mm-hmm.
Well, maybe we should look at the code. Can somebody look at the code and see if it has comments?
That will I could not in real time because it'll I'd have to search for it.
Yeah, okay. We should look at that. I had no idea. No idea. Something hidden deep in the infrastructure of the world, so to speak.
Mm-hmm.
Okay, but back to, okay, let's just zoom out again. What are we trying to do? As Michael says, when we type plus in the axioms of field theory, we're doing it because it resonates, it reminds us of plus, but it no more reminds us of plus than when you type PLUS in the name of a symbol, which we're doing so it reminds us of plus, even though it's lowercase p. It's kind of a light, hat tip to plus. It's not intended to be, it really is plus. It kind of, it looks like a duck, but it isn't a duck. I don't know if that's very useful. But so the claim is, the only thing we're trying to use, the only thing we want to use is special forms of operators and their precedence. No, it's more than their precedence. And their precedence and the way that they pick up arguments, like A plus B going to the full form, right?
Right.
That's not quite precedence.
They're parsing info.
Right. And their basic parsing. See, the question is, what's the analogy between this and your average piece of tech input that might have completely meaningless uses? I mean, like for example, one can imagine a notation in which people are using, I don't know, some operator which is normally a binary operator, let's say XOR, but you're using it as a prefix operator.
Well, people do that all the time, right?
I know they do.
If they're doing, some sort of XOR over an indefinite number of variables.
Exactly, right. But my question is, when people type right now, when people type arbitrary tech, we are not really seriously trying to parse it.
Correct.
And I think that is hopeless to seriously try to parse it. So in a sense, again, we are inventing, okay, what are our choices here? We can have something which is a complete grammar for formal things. Then the question is, what operators are we using, and what symbols and operators are we using in the land of formal things? And if we have a whole nother family of those, okay, then there are two questions. What operators are we using, and how do you type them? Right? Because that's one of the problems, is that it becomes extremely hard to type these things. And if we had a way of sort of formalizing stuff, okay, the question is, a parsable string.
Okay, so can I just mention one of the reasons I don't particularly like the idea of just like a slash formal plus, like we have slash formal a, which I think is kind of what you're assuming when you say to formal expression. One of the reasons I don't like that is for full generality, again, at least in the theorem proving case, we need to be able to have multiple different formalized copies of the same operator within the same axiom system.
Why?
Right? I mean, well, so imagine the case of axiomatizing vector spaces or modules or something. Like there you have, there's addition of in the underlying field of scalars, and then there's addition of the vectors. And those are two different operations.
Yep.
But they're both denoted with plus.
Right, or algebras are even worse, right? Because you have
Right.
scalar multiplication and vector multiplication, which is something completely, in the module case, you see the straight line between the two additions, whereas in the algebra, they're quite different.
Okay,
Exactly.
question. How much is there a taxonomy of these kinds of things? Like you say, there isn't really. I mean, there could be a scalar plus a tensor plus a vector plus a tensor plus an axial vector plus who knows what.
Right. The point is that the plus symbol carries a lot of weight. There are lots of essentially different operations that are denoted with plus, many of which can occur within the same algebraic structure. And so we need to have some way of okay, my point is that a slash formal plus or something is not sufficient. We need some.
But where's the slash coming from? You mean the dotted?
Yeah, he's referring to the long name, the backslash open bracket.
Oh, okay.
Right. Anyway, we ideally would want some kind of parameterized version of that, if that makes sense.
That makes
right,
sense.
which I think is where you were going with the container that is somehow tagged idea, right? So you have like a formal of string plus, scalar plus, and formal of the string vector plus. And I suppose if you're doing tensor analysis, right, then you need 1 plus for each rank and the kind of tensor, right? Because those are technically different pluses as well.
Right.
If I may say, I think we're having a similar discussion to the previous time, in the sense that this was motivated by, we need more operators. And so I said, well, let's have just a few more so that we cover our new needs. And then we went to let's solve the whole problem of having any. But I think this other problem is too difficult.
Which problem? The problem of the any?
Of the any number. Of the parameterization. This is a space too big to parameterize correctly. And if we give names like tensor plus or something like that,
hopeless.
users
it's
will
hopeless.
be forced.
It's hopeless. Yeah, that's hopeless. I agree, that's hopeless. Okay, so let's zoom out for a minute, okay? The thing that's been very successful is our fundamental symbolic expression form with words, names, character strings that represent things has been thoroughly successful over the years, right? Not a problem. Now, what's the difference here? Okay, I've got an idea. Okay, so the difference is we're trying to push into a single character all this functionality. Now, we already have something, which is the tilde operator, which has not been particularly widely used. But that is a way of essentially merging syntactic it's a way of merging an infix operator, but with a name, right? So for Jonathan's, scalar plus, for example, right? We could perfectly well, this isn't very elegant, but, this would be a thing, right? That would just work.
Right. I mean, you would just need to, right. It would have the natural precedence of infix, which is very high. So you
okay, so there's a precedence issue. Yeah, there's a precedence issue here. Now, and I wonder how we solve that. But the point that I'm making is the way to deal with the any is to have sort of meta operator wrappers, so that the operators can be named the same way we've been naming things for 35 years with strings of characters. Okay, so let's imagine that the meta operator wrapper, okay, this is starting to be a decent idea. Let's imagine that the meta operator wrapper could have things like plus inside it, that it was similar to the way that we do meta things for, I don't know, less than, can deal with, slashes and things like that. In other words, it switches off. By the time you've used the meta operator, it's switched off the usual parsing of what's in the inside. Do you see what I'm saying? But that somehow this could
So I mean, it's something we could explore, but off the top of my head, it is not at all obvious that that is something that's even parsable. I mean, obviously it's not now, but I'm just saying it's not obvious to me that this is
right. But clearly, if that was an escape, yes, I understand.
Although I guess we don't have any compound operators that use tilde, so maybe.
I'm not claiming this particular thing. I'm not.
Oh, I see.
This particular thing. I'm just saying some meta operator that wraps an arbitrary packet of operator-like stuff, and potentially gets the precedence, if that's doable. I don't know if that's doable. Gets its precedence from the payload. Right. So what we would need is. So this is the idea. That's the meta operators wrapping, payloads, and so the meta operators would be a meta. We'd have this sort of meta operator, which is the prefix meta operator, the postfix, and so on. And then infix, meta, etc., the bad names, but whatever. I mean, I think this is the only doable thing, because this allows us to get the any idea, and if those, for allowed arbitrary things in here, the full form of this object would be. What the heck is the full form? The full form will be some kind of, formal operator of, plus, comma, blah, 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 and then applied to the expression. See what I'm saying? So formal, the full form will be pretty heavy, but that's okay.
Yeah. Obviously, this is something I would need to discuss with. I think this would be doable in the front end, but that's something I need to discuss with.
Well,
Tom.
right. I mean, we have to. The question is what the meta operators, how the meta operators work, right? Because, and the real question is letting precedence seep out of the innards of the meta operator. You know what? Given what Jonathan has said, if we're serious about using, I mean, gosh,
I mean, we do have a small number of things where like sum, right? That's an operator, and you can turn it into a sub-superscript or an under-overscript box, and it still has the precedence of sum, because
I get it.
So, I mean,
Right, but maybe this is a general mechanism. I mean, maybe what we are doing here is inventing a general mechanism for introducing. So then maybe we have two different problems. We have, you know, these things don't need formal variables. We need because we can assign values to variables. I don't know, but we're making progress here. This is not a bad idea. This insight that we need to leverage the high diversity way of labeling things, which is with character strings, seems like a good insight. That we're not going to be able to stuff it into, you know, oh, we'll introduce another, you know, a triple tilde just to represent that. That's basically, that's the import of what Jonathan is saying. Is that a fair statement?
I think so. If we want a long-term solution,
always a good thing to have.
I mean, on the other hand, if we just care about kind of making axiomatic theory more extensible, then I think Jose's idea is not a bad one, which is just have more things that are like circle plus and circle times.
But
but it's going to get very obscure. Go ahead.
But we might want some of the things not just for representation purposes, but for actual computations. Like you have some associative algebra, and you want to really add rules for computation rather than just sitting it there.
So what? I mean, you can add rules for circle plus.
Yes, but you can't add any things to the formal ones. So they would be different as formal operators. You could add rules to them.
Well, you could always do replacements, right?
Yes. Yeah.
I don't know whether adding rules to them. I mean, that's a whole nother question. I mean, then we've got things like the combinator disaster of, you know, of you can't add rules because not all evaluation orders terminate, and it's all rather complicated.
Yeah, but it's then up to you to add rules that do something sensible.
Yeah, but is that in fact common? That the canonical form? Because I mean, one thing is use the theorem prover to get to a canonical form. The other is, which is allows you a multi-way story, and the other way is use our traditional evaluation semantics to get to a canonical form. And do we think the traditional evaluation semantics is going to be a common thing?
Let's say you want a nicely a commutator.
Mm-hmm.
Yes, you can write com of something. You can make some format rules for it and everything.
Yes, right. All right, we are making progress, guys. We should pick this up again, and we need to. This is one that it seems to me we've got several. We're just finishing a version, so we get a chance to think about bigger things. We've got several things from the string diagram stuff to these formal variable things. These are some heavy lifting, and they're things that have been around for multiple decades. But I think we should now feel ourselves empowered to solve them. That's my theory, at least. Anyway.
All right. Okay. So just so we're clear, so are you saying we should resume this discussion in our next meeting, or that we should go and wander and come back?
I think we should probably if there's a few specific things to go look at as homework, but I think we should resume this.
Okay.
And either in this meeting or in a custom meeting.
Okay.
All right. Thank you all very much. Thanks to folks on the live stream, and talk to you all soon.
Okay.